composition is the percent by mass of each element in a compound. There are experiments that you can do to determine the percent by mass of each element, say in a fuel. You can determine the percent of the mass due to carbon versus hydrogen and so on. And once you have those percents, you can also work backwards to get the formula. But anyway, it's useful for different reasons. First, we're going to see how to calculate it, and then we're going to see, if you have the percent composition, how you can come up with the formula and identify the compound. So calculating the percent composition is the easiest part. You just use the formula and the molar masses to get the percent by mass. So when you calculate, so for this compound, the first thing you do is you calculate the molar mass. And you can think of that as like the total mass of the whole compound. And then you can see what percent of that mass comes from each element. So this part was from carbon, this part was from hydrogen, and what percent of the 16 came from each. So this is pretty simple. The percent of carbon by mass will be equal to 12, because that's what it was in that formula, divided by 16, the total, of course, times 100. And then for hydrogen, I'm getting this from here. It contributed 4 to the total of 16. Okay, and this is what we mean by a percent composition. It's these two numbers right here. Before we get into how you can use the percent composition to get the chemical formula, we need to talk about two different types of chemical formulas. And I'm actually going to do a little bit of notes down here before we get into what this slide says. So let's just consider a compound. There's a real compound called hydrazine, or dihydrogen tetrahydride, but anyway, that's what it looks like. Its molecules look like this, and it's kind of hard to get the H's in there, but they're there. Okay, and so N2H4 is the real formula for that, and that is a molecular formula. Okay, and the molecular formula shows what is in one molecule. So we always think of that as the correct one. But we could do something called a empirical formula as well. An empirical formula is the same elements, it's just reduced. So for this compound, the empirical formula is this. I've reduced the 2 and the 4. So we can see an empirical formula doesn't really represent the compound, but it does have some meaning because its percent composition is going to be correct. It will be the same as this one. So empirical formula is just sometimes used as a tool to understand a compound that maybe you don't know what is exactly is in one molecule. But anyway, so that's kind of the difference between empirical and molecular formulas. So empirical is the lowest whole number ratio. And so let's consider the compound on the slide now. This is the empirical. So in other words, that's the reduced version. When we see a molar mass, this molar mass is for the molecular formula. Okay, it's like the total, so it would be for the big one. What would the molar mass of the small one be? If this is the reduced, what would its molar mass be? And so to get it, we would say 12 for carbon plus 2 times 1 for hydrogen. It's 14. Okay, so we have the molar mass of both the full version is 42, and the reduced version is 14, and we know what the reduced formula is. So basically what we need to figure out is how many multiples of this do we need to use to get up to this 42. And if we can figure out that, then we can figure out the true molecular formula of this compound instead of just the reduced one. So, and a good way to think about it is, how many multiples of 14 do you need to get up to 42? And so to do that, what you're going to do is take the known molar mass, which is 42, and divide it by the empirical formula's molar mass, which is 14, and that gives us 3. So this is our factor that we're going to multiply by. So CH2, this is the empirical, its molar mass was 14. And if we use a factor of 3, we get C3H6. And if you calculate that, that's 3 times 12 plus 6, that will give us a molar mass of 42 grams per mole. So therefore, our molecular formula is, this all makes it sound more complicated than it really is, but we need to kind of get these words straight, that basically the difference between the empirical and the molecular formulas is that the molecular is a multiple of the reduced empirical formula. Okay, well, once we understand these types, we can put that together with our percent compositions to figure out molecular and empirical formulas. So these are the steps to go from the percent composition. Then you can find the empirical formula by converting to moles. And then if you have a molar mass available, you can do the step we just did to get to the molecular formula.